Hey guys, today I'm going to be discussing Kirchhoff's voltage law, otherwise known as KVL. Throughout this video, I'll be showing you what Kirchhoff's voltage law is, how it works, why we use it, as well as briefly going over a few basic examples of questions involving it. What is KVL? In 1845, a German physicist by the name of Gustav Kirchhoff came up with a theory based on the law of conservation of energy. His theory stated that the algebraic sum of the potential rises and drops around a closed path must equal zero. This can be mathematically expressed as the energy source minus all the various voltage drops across a conducting path must equal to zero. The water pipe analogy is a great way to further clarify exactly how KVL works. Suppose we had a series of pipes connected together such that they formed a continuous circular loop. Inside this loop, there are areas where the water pressure rises, created by pumps, and other areas where the water pressure falls, created by restrictive or narrow tubing. The pumps correspond to what we call voltage rises, otherwise resembled by battery sources in a circuit. The restrictive areas correspond to voltage drops, otherwise resembled by resistors. Why do we use KVL? KVL is one of the fundamental laws when analysing circuits. KVL comes in handy when we are asked to solve for a particular voltage drop or calculate the voltage coming from a power source. In this example, we're given the value of three resistors, R1, R2, and R3. And using Ohm's law, we can actually calculate the voltage drop across each one of them. Now, by directly applying Kirchhoff's voltage law, we can now find the supply voltage. Likewise, if we were given the supply voltage and the values of two resistors, we could solve for the third using Kirchhoff's voltage law. Let's take a look at a slightly more challenging example. We will first begin by differentiating between the voltage drops and rises by labeling the polarity of each circuit element. By now you should know that all resistors result in voltage drops, so a positive terminal should be drawn first. But let's take a close look at battery 2. You may notice that it is opposite to the configuration of battery 1. This means that we take the voltage to be a drop, meaning that the positive terminal comes first. Now all we have to do is apply Ohm's law to find the voltage drop across the resistor components and sub our values into KVL formula. If your algebra is correct, you should get that R2 is 4.5 ohms. I hope this video has improved your understanding of KVL. Thanks for your time.